Well, folks, thank you so much for spending your time with us. You know, there's nothing more important than finding a place that you feel cared about. I want to share a little something with you that came to me the other night at 3 o'clock in the morning. It's kind of the time of day that I do a little meditation. And it said to me, little voice came up and it said, all of your future road will be paved by the thoughts that you energized in the past. And I'm thinking, wow, my thoughts are going to pave the road in front of me. I better watch my thoughts. So when you have some thoughts that you don't care for, make up a little saying like I do. I say, peace on earth. And I give myself a little chance to break that thought that was going to take me away. So thank you all for being here. Welcome. And with that, Casey, it's all yours.
Hi, everyone. It's nice to see you all again. Tonight, our speaker is Bob MacDonald. Bob MacDonald is a technical program manager focused on projects that apply AI techniques to solve problems related to disabilities and social good. This includes improving speech recognition for those with impaired speech, as well as driving innovation in other assistive technologies. His prior work at Google involved using AI to improve cancer diagnostics and to improve access to health vital signs. He also led teams developing next-generation imaging systems used for products like Google Maps and StreetView. Please join me in welcoming our amazing speaker for tonight, Bob MacDonald.
Hi, everyone, and thanks for the introduction, Casey and McFinn. It's really a pleasure to have the chance to talk with some of you and share with you some exciting news about tools that hopefully some of you can find useful, and if a tool isn't necessarily the right thing for you, then maybe it's the right thing for someone that you know. As Casey mentioned, I'm a technical program manager here at Google, and we work on a wide range of systems at Google. The ones that I really have been focusing on recently have been associated with communications. Whether it's speech recognition, text entry, like for assistive typing, or other ways that we communicate with our words and that we either say or write down. That's kind of the main theme that's woven through the last 5 or 6 years of my time at Google. And I'm very excited to share with you a little bit more detail about a product that we've developed really as a consequence of collaborations with the ALS community going back 4 or 5 years. Though the end product that I'll give you some details about really is something that we think could apply to and is really kind of tailored to users, from a wide range of humanity, for whom speech recognition technologies don't work very well. So with that being said, let me just share a quick little video snippet from one of the people that we've worked closely with as kind of what we call a trusted tester. So this is someone who has had an interest and has had some energy to work extremely closely with our team to help us make sure that we're developing products that actually are as useful as they can be. So let's see if this is going to play for everyone. Sorry, let me. Okay. Trying to get this to.
It's kind of like a fight for that, but I got into the public school.
Could you turn on listen so I can see what transcript of what you're saying? You were just got to the point of saying that you got into public school.
I kind of hope.
Okay, so you're seeing two people here. The second person, the woman that jumped into the video, is Katie Seaver. She's a speech and language pathologist that's worked with our team for a couple of the last 3 or 4 years, and she's having a video call with a trusted tester named Bill. So I'll play this for a little bit longer just to get a sense for the type of use case that I'm imagining is something that's going to be fairly common with folks that you know or with yourself. Oops.
Kind of public school, and it opened up a whole big thing for other kids with disabilities to start going to public school. Kind of public school kids with, and I started a couple years after. A lot more kids being in my school. And then I went to, then my parents moved to Florida. And I met a lot more people.
Okay, so this is an example of how technology like Google Meet or Zoom or other kind of video communication technologies can break down for many users. And overall, there's quite a large population of people whose speech is different enough from kind of the typical speech patterns that speech technology really fails to work effectively for them. And so of course, this is a situation that's going to affect many people in the ALS community through the disease progression, but there are many other factors that can affect someone's speech, whether they're factors that are that someone is born into, like Down syndrome or cerebral palsy, or something that developed later in life, and so we actually started a research project back in 2018 that started with kind of a different aim, that was really looking more at how can we diagnose disease progression using speech as a more objective measure than the technologies and the standard operating procedures at the time. But we realized that there was a chance that we could have a more significant near-term benefit by adapting technologies that could help improve people's communication in this community. And more broadly speaking, the team behind this research and the product that I'm going to talk about is we call it AI for Social Good, and that really represents a range of different projects within Google that are looking at applying technology, and more specifically AI or artificial intelligence, to some really big challenges that we think have the potential to help out people and humanity. And in terms of this specific set of researchers and projects, we've looked at the intersection of accessibility, speech, and kind of basic computer science technology as where we focused our attention. So before jumping into more of the specifics around Project Relate, which is actually a product that's available now for free, I want to back up and attempt to do a little bit of demystifying of what AI is, at least in the context of the research that we've been doing and the products that we've been developing to improve kind of verbal speech communication. So let me first start with kind of one very high level description of what AI is in this context. So the historical way of using computers and programming them to do tasks like recognizing speech or recognizing objects in images was to come up with a set of rules. So on the left-hand side of this page, you can see that there's a kind of a rules-based approach to programming the computer to recognize spam, where you might have humans that are actually trying to come up with examples of words that might be very common in spam emails that are sent around. An alternative way of programming the system is to let the computer system itself determine what the rules are by giving it a bunch of examples. And this really reminds me of the way that my children and probably almost all children learn to talk. They typically don't start with an explanation of the rules of grammar and a list of vocabulary words. That usually is how we learn a second language. But how we learn our first language typically is we point to objects, and then someone who already knows how to speak describes what that is. That's a bicycle, that's a tree, and through that accumulation of examples, the new learner actually figures out what the rules are without ever having to be told that a bicycle has 2 wheels and handlebars, and a motorcycle has 2 wheels, handlebars, and a motor. So machine learned systems are ones that have really become the most common and the most effective at solving many tasks today, and that's going to be the focus of the following research that I mentioned, and it really is sort of what's under the hood of the products that we've developed. So this next page shows you an example of one of the classic machine learning successes in the last 5 or 10 years was building these computer vision or machine learning models for image recognition. So teaching a computer to recognize whether an image has a picture of a dog or a cat in it. So this kind of simple description shows a cartoon picture of a dog and a neighboring one with a cat. And then there's an arrow that shows kind of a very dense grid that's connected to a slightly smaller grid on top of it, a third grid on top of that, and finally a fourth grid that just has 2 points. And that final one is the one that's supposed to determine whether there's a cat or a dog. So you start with an image that has a lot of pixels in it, and basically what this picture is showing are some mathematical calculations going from one layer to the next that ultimately result in the computer trying to decide whether that's a cat or a dog. So that's just sort of a way to think about how these systems work. They basically take an input, and then there's a sequence of mathematical operations that happen, and at the output of this system, there's something that hopefully is useful for someone. Now, in this example, we show a more complicated picture of a cat hiding behind some plants. How does this system know whether there's a cat or a dog in that picture? Well, the answer is it really depends on how effective the training has been. Has it seen enough examples to be able to kind of see through those plants and see that there's a cat hiding behind those plants? There's no guarantee that it will be right. And that situation really applies to speech recognition. So speech recognition systems like the ones that provide captions for video calls or for YouTube videos, they take the the sound, the signal that's generated from the microphone of whoever is speaking, and they try to then convert that that audio input into a series of words, the text that someone is speaking. And I show that here through a series of 4 different little bubbles. The first one is indicating the raw audio signal. That's just the microphone's output as it's listening to the speaker. Often one of the first things that happens is that that signal is turned into something that looks actually kind of like a visual representation of the sound. And then that visual representation is then put through a series of mathematical operations like the ones that I showed in the previous slides based on images. And the output of that is a series of letters or words, and ultimately, the sentences that someone is speaking. So we call that real-time transcription. And that all is a very well-established approach for converting what someone is saying into text. But it doesn't work very well if the person who's talking is not, the style of their speech is not very similar to the type of data that was used to train that model. So, and there are many people in the ALS community, many people in the cerebral palsy community, in the many people who've suffered a stroke or traumatic brain injury, and any innumerable situations that can cause someone's speech to sound different enough that it's hard for these systems to understand them accurately. Indeed, depending on the severity, it can be hard for another person to understand them. I know my personal connection to ALS dates back about 25 years when my sister's husband was diagnosed with ALS. And he was in his early 30s and progressed quite rapidly. We lived across the country. They were on the East Coast. I was on the West Coast. And so, I wasn't around him often enough to really be able to kind of reprogram my own brain to, understand him as accurately as my sister could. And so, I've seen this firsthand that, if you have enough examples and enough experience, generally as a human, you can understand someone whose speech is changing. But if you're only an occasional visitor, or if you're, if you just don't know that person previously, it can be very hard to understand them. And, these are the kinds of situations that really motivated our research. And we knew that one of the key starting points for this was going to be to hear from enough people with voices that aren't well recognized, well understood by today's technology or by other people, so that we would have a chance to have a diverse enough set of data to really train these models to be better listeners and better recognizers. So what's shown on the screen here is kind of a simulation of a computer screen, and right next to it, the screen of a mobile phone, which was where the user of that device was providing some samples of their speech. And we would basically show them something like a little flashcard, just one phrase or a word or a short sentence. They would record themselves saying that sentence and then move on to the next one. And by the time we have several hundred examples like that from a given person, then we have enough data for our researchers to do some pretty amazing things. One of the nuances of this approach was trying to figure out, well, what do we ask people to say? There are so many different things that anyone might say in the course of their day that we did have to be fairly intentional about what prompts we gave people so that we could have a better chance of doing something useful for them rather than just kind of getting random sentences. So we focused on two broad sets of situations where someone might say something. The first one is when they're interacting with technology, with a phone or with a computer, typically, or with a home device or the voice-activated device. So the kinds of things that people might want to do there are often sort of commands where they're changing a music setting or a TV channel, or they're adjusting the lights or the temperature of the room or whatnot. The second one was interacting with other people. So other people could include caregivers. They could just be any conversation that you're having with someone else. So we tried to construct a series of text prompts that would reflect a reasonable range of those types of interactions. And through the course of about 4 years, we were able to collect speech samples from a few thousand speakers whose voices were different enough from normal that, in their own estimation, technology didn't understand them well, or other people didn't understand them very well. And in total, we collected over 1 million different utterances. So hundreds of utterances for each person. And this really formed the basis for our researchers to try to make improvements to the technology. That gave us enough variety of what people are saying, enough variety of speakers in terms of their age, their gender, their condition, maybe their the region of the country that they grew up in, so their accent. And this was all made possible by working in partnership with, you can see on the upper left, ALS TDI. That was our original partner that kind of inspired this whole effort. But we expanded to a lot of other organizations, including those working with people in the Parkinson's community and in the Down syndrome community, as just to name a few. Okay, I'm a couple slides away from getting to the real punchline here, which is that the output of this research actually allowed our team to figure out a formula or a recipe or a technique to make significant improvements to the accuracy of our speech recognition models. So there's a graph here that for some people might be pretty complicated. I'll try to explain it briefly, what we're showing here. But the real bottom line is on the left-hand side, that when we took our out-of-the-box speech recognition model, that's the one that was used for most mainstream products where Google takes speech input and turns that into a text output. And we tried to adapt that with speech samples from a specific person. We could reduce the word error rate for 75% of the people to a level where it was accurate enough to be useful. And this includes people with speech that was very, very hard to understand, as well as people where they just had a mild impairment. And over 80% of the people who contributed their voice samples, we were able to adapt a speech recognition model where the accuracy was over 85%. And that was kind of our rule of thumb for when we figured the model might be accurate enough to be more useful rather than more frustrating. And basically, the graph on the right shows some of the statistics behind that the red boxes are the model, the accuracy, or the word error rate, which is kind of the opposite, the inverse of accuracy for a personalized model, compared to the green one, which is the unadapted or the standard model that hasn't been trained on any one specific user. The green dots and boxes tend to be higher. That means that the error rate is higher, the frustration rate is higher, the usefulness is lower. And you can see that the red boxes and the red dots tend to be much, much lower. Okay, here I just show a few of the papers that we've presented on this research, and that tried to help lay out the roadmap for any other research teams that wanted to do something similar. But really what's most, I think, relevant here is that it was successful enough that it inspired the team and powered us to kind of get executive support to actually build a product out of this. And that was all really due to both the combination of the thousands of people who contributed examples of their voice, and every voice is unique. We just needed to hear, a wide enough range of them, as well as the people that, went kind of above and beyond as trusted testers, some of whom are shown in this picture. So we spent the next couple of years working to actually make a product that people with ALS and others in these kind of target communities could use on a daily basis to help improve their communication. And more information about the product is at the website that I've listed here. It's g.co/project relate, just those two words smashed together. And the goal of Project Relate is to make speech recognition work better so that people can communicate better when their voice has changed or is different. So this is a little bit more detailed overview now of what Project Relate is. So first, let me kind of clarify what it is and what it isn't from a technical standpoint. It's an Android app, which means that anyone with an Android phone can use it. Regrettably, it's not yet on any other platform, like desktop platforms or iOS, so it won't work on an iPhone, but it will work on most modern Android phones that are, say, less than 5 years old. It's available right now in English in many of the primary countries, the US, UK, Canada, Australia, New Zealand, as well as a few where there are a large number of English speakers, such as India and Ghana. And we're working to expand its availability geographically, and ultimately our ambition is to expand its availability in terms of the languages and in terms of the platforms. But that's that's kind of the longer term aspirations. And the way it works is that when someone first downloads the app, they're asked to contribute a few hundred recordings so that our system can be trained to understand their voice. And what it's doing with those samples is it's retraining a speech recognition model based just on their speech. And when it's successful, then it will let the user know that it believes it's developed a model that can understand them accurately enough that it will be useful for them. And they'll get a notification, and at that point, then they can do one of three things. The first one is we call real-time transcription, or listen mode. And what that does is that allows the user to talk into their device and have a text transcript of what they're saying show up on the screen as they're saying it. The second mode, we call it repeat mode. There might be some situations where someone would rather not have their speech turned into text, but rather they would prefer that it repeat what they said, but in a normalized voice. So maybe they're trying to talk to a device like a Google Home device or an Alexa, or maybe they're trying to order at a restaurant and it's not convenient to show their screen to someone, and they want it to basically come out as a reverbalization of what they said. So that's the middle case that we call repeat mode. And then the third one is maybe they just actually want to use their voice to interact with the device, like find out what the temperature is going to be tomorrow, or do something else with the Google Assistant, or do a search, a Google search. That's our third mode in the Relate app. So I'm going to show you a little video of one of our trusted testers who's actually a brand manager at Google, Aubrey, who is going to show us how she puts this to use.
Communication is a fundamental human need, and I think it's also a basic human right. I'm Aubrey Lee, a brand manager at Google. More specifically, I'm a namer, and it's a lot of fun to say that I'm a professional namer. I have a type of muscular dystrophy that affects the way I speak. I have always loved making new friends, but when people can't understand me at first, they have trouble getting to know me. It's as if there's an invisible barrier between us. I believe technology can help bring down that barrier.
My name is Julie Catio. I'm a product manager at Google in the research team. Project Relate started in 2018 when we realized that our speech recognition technology could be improved to help people with speech impairments be better understood. Standard speech recognition doesn't always work as well for people with atypical speech because the algorithms have not been trained on samples of their speech. So we decided to create an app that would be custom trained on individuals' unique speech patterns.
We named the app Relate because of what it enables you to do.
To use the app, the first step is to record a set of phrases so it can get to know how you speak. The Relate app has 3 built-in features: Listen, Repeat, and Assistant. Listen transcribes everything you're saying in real time.
So I have a custom voice model now, and
Repeat repeats what you've just said in a clear computerized voice.
next thing I do, hot chocolate.
Hot chocolate.
Ah, gotcha.
Thank you.
Assistant connects directly with your Google Assistant.
Take a selfie.
Okay, get ready.
I hope I live to see the day when disabled people can move through the world and expect the same level of connection as everyone else has. I think Project Relate is bringing us closer to a better future.
Okay, so I think that really captures the essence of what this is about. I'm gonna actually skip over the next example, but I do have some more details here around kind of the target market for Project Relate, and I'm happy to kind of share that out more broadly. But I wanted to make time for more questions here. One other thing, I know this audience is probably primarily an English-speaking audience, and most of the work that we've done with Project Euphonia and the first release of Relate, as I mentioned, has started with English. But we know that most of the people on Earth aren't English first speakers, most of them probably don't even speak English, even as common as it is. And so language expansion is something that we really find is going to be important for realizing the long-term vision. And so where we are now with the research under Euphonia is we've started collecting data from people who speak Hindi, Japanese, Spanish, and French. Ultimately, we want to develop a recipe that can allow us to more efficiently scale to many, many languages. So that's kind of the focus of the research side. And the focus of the product side, Project Relate, is just getting this in the hands of as many people as possible, so you know that those that stand to benefit from it can. So I will stop there and open it up for questions.
Thanks, Bob, for your amazing presentation. I'm looking right now to see. So the first one is, does this app work on a Chromebook?
Not yet. We hope that it will get to a point where it will work on a Chromebook in the next year or so, but right now it basically is limited to devices that are running the Android operating system.
And then,
Go ahead. I'm sorry.
no, you're all. And then can you say if this technology is in Google Meet yet, or is it only in the Android app for now?
Oh, that's a great question. It's only in the Android app, but let me show you what some of our users who have that have been doing with it. They basically do a screen share when they're in Meet. And let's see if this little video will give people a picture.
I did public school, and it opened up a whole big thing for other kids with disabilities to start going to public school.
Okay, so it requires a little bit of work to set your system up so that the Relate app running on an Android device can join the Google Meet and have the text be visible to everyone. So that's sort of our workaround until it's available directly in Google Meet.
Are you able to say a bit more about how you set that up?
To say a little bit more about which?
How you set that up?
Yeah, about how we set that up. Feel free to drop me a note, and I can connect you with folks that will be able to explain how to do it.
Thank you.
Yeah. And then, Carl, I see that you also had a question in the chat about the timeline, say for integration with Meet or Chromebook.
Yes.
Yeah. Yeah, I wish I could give a high confidence timeline, but you know, we don't have a near term kind of schedule for some of these upcoming launches. So almost certainly any of this will be, we're looking into 2024 at the earliest. And you can always check back at g.co/Project Relate for updates. That'll probably be the most accurate way to figure out what new platforms and/or languages this will be available in.
Thank
and I see,
you.
yeah, you're welcome. And I see Diane, had a question about iOS apps. Basically kind of the same answer there. We really hope to expand this to be available everywhere and anywhere that someone needs it. Okay, I see a couple of questions related to like the level of impairment, or the threshold where the technology will not be able to discern, and that is true. There are, and I know personally speaking from my brother-in-law's experience, at some point, his disease progression got to the point where my sister couldn't understand him, and there was just no, the ability to form words, had degraded. I don't know how to quantify that, but I should mention that several of the same team members have been working on ways that we can improve text entry for people using eye gaze systems or other input devices, and to speed that up and make it more accurate. So we know that it's a journey for many people through which even a huge amount of data wouldn't be enough for us to train a system to recognize, and we want to improve communication even at those stages.
The question about voice banking, Bill says this is not the same as voice banking, right?
That's correct. So in some way, it's a little bit not exactly the opposite, but complementary. In an ideal scenario, people who are voice banking will do that early enough that the way that they speak sounds as intelligible as possible and as close to what they've sounded like before the disease started to affect their speech in a significant way. And the data that we need for this system is actually the way that you speak after your voice has been significantly affected. So they're both important, and anyone who does recordings for Project Relate can get a copy of all of their recordings. Those could be copied over to a voice banking provider, in theory, but I'm not sure that it would be the right quality to replicate.
There's another question about recording. How often do you need to provide samples as ALS becomes more impaired with progression?
Yeah, that's a fantastic question. I wish we have done enough research to have a really quantitative answer for that, but that's an active area of research. And we've had a number of participants who've done recordings spaced out by several months, say through the course of a year. So we're trying to answer that question, but right now we don't know what the answer is. It might be the case that as your voice degrades to a degree that it changes how many people understand you, that you've got to provide another 100 samples, and then that will initiate a retraining of the model. But that's kind of the best remedy that we have right now. We don't yet have a really clear boundary beyond which more data would be needed.
I did see a comment. I'm so sorry. I saw a comment Carl in the chat that said, just FYI for others in the meeting, I've used Project Relate and it does work amazingly well for my speech. And I have a significant speech disability.
Yay, that's so great to hear. It's going to work for what we found. It will work for most people, who can, still, utter words and sentences. There are some cases where the formula that we developed, didn't make an accurate enough model, but that was a small fraction. So I really encourage as many people as feel inspired to give this a try, to to try it for yourself.
One more question. My issues in hand function. I've tried using voice typing, but it's a hit or miss. Would this kind of system help get better recognition of non-impaired speech too?
Oh, yes, it will. In fact, some of our colleagues have found it useful, like maybe they're using their voice input and they want to whisper, because maybe they work in an environment with lots of where it's just not appropriate for them to speak at a normal volume, or for people who maybe they're wearing a mask and that's distorting their voice. So we do have a number of people that have found Project Relate to be useful for voice typing, and it does improve the accuracy. One of the other use cases that I should mention is that I talked before about the phrases that we provide in these sort of electronic flashcards. Project Relate also allows the user to add their own specific words and phrases. So these might be names that are really important to them. They might be entertainers. They might be songs. They might be food. Diction related to food, or anything else. So you can personalize that list. One of our users is a mathematician, and he gives talks at conferences where he uses a lot of very uncommon mathematical language. And so he's trained the system to understand, these mathematical words much more accurately. So I would encourage you to, give it a try, David, and see if that might make it, that voice input a more effective way to input text.
Does anyone else have any more questions for Bob? You can just unmute yourself.
Bob, does Google supply the telephone, the Android?
No, we don't. We basically provide the app for free, and there's no cost to do the training or to use it. But we don't provide any hardware. We've worked with partners like Team Gleason, who, their mission includes providing more complete solutions for people, including hardware where it makes sense. But that's not something that our team does.
Do you know how long it'll be before iPhone can be included?
No, I don't. In all candor, I'm not optimistic about 2024. So, it's on the longer term planning horizon. Right now, we're trying to expand languages. And that's a pretty big effort. So I want to, unfortunately, I probably have to set low expectations. Maybe something will, there will be, an unexpected pleasant surprise, but it's probably going to take longer rather than shorter.
How many people are on your team?
That's a good question. Well, I like to think of our team as an extended team that includes the trusted testers, some of whose videos you saw and more whose pictures you saw, data contributors, thousands of them. In terms of, say, the people whose full-time job it is to work on this, that's a much smaller number, of kind of the order of 10. But that also really depends on the phase of the project. So we had a bigger team during the development. There's a lot of work that needs to be done to build the tools to train that speech recognition model. Once that system is in place, that team can go and build other what we call infrastructure. So it's kind of ebbed and flowed from probably 5 to 25 people over time.
Are you looking for any more volunteers from ALS patients?
We always can use more volunteers in terms of the speech samples. That the more variety of voices we hear from, the better we'll be able to do. Our next major goal, I should say, in addition to languages, is to have a data set that is representative enough of the variety of speech patterns that we can convince the team that builds the generic, let me call it, the non-personalized speech recognition model to include all of this data and at least make that starting point much more accurate for these communities. So that's one thing that will benefit the community broadly speaking, that it might take longer before you really need to do something like use Project Relate, because the system just does understand people that sound like you better than it has historically. So that's kind of the main way to get involved now.
Thank you, Bob.
Yeah.
Okay, further questions?
I see some comments and a few questions from Carl in the chat. When I use relate, the WER is lower the more I articulate, and then can I retain the model with less articulation? And what does your research say about that?
Yes. Okay, that's a very good question, Carl. And let me kind of use an analogy. I mentioned one of our partners works with people with Parkinson's disease. That's a condition where people, many people with Parkinson's have their speech affected. Often it just becomes very soft and not crisply enunciated. But there are interventions whereby people can really sort of perform the speech process and be more intentional when they're talking. And what we tell them is we'd rather hear examples of their speech when they're not having to try so hard. Sort of the ordinary speech that if they were just talking and not thinking so much about the quality of their speech, that's how they would talk. And we find that when we get that kind of data, our model is better able to be adapted to understand that speech. So I think the same thing you might find the same thing, Carl, is by providing the system with more examples when you're not trying to articulate, so intentionally that the system will be able to kind of track that speech. I can't guarantee that it will be more accurate than when you are trying harder to articulate. But we found in many cases that does work out, that just providing examples of the speech with less energy in the articulation can improve the word error rate.
Thank you.
I see a question from Jeff on Google Docs. Prevents Mac OS on-screen keyboard from doing Word autocomplete. That is an accessibility issue. And there are teams within Google Workspace. Google Docs is kind of part of the Workspace product suite that focus on accessibility issues. So I can't guarantee that that there will be a quick fix to anything like that, but I do know that there is a team whose primary job is to hear about these kinds of accessibility issues and try to prioritize them and get them fixed, in a logical sequence.
I see one more from Bill. Is this only for people who can still speak?
Yes, so Project Relate is only for people who can still speak. What I will, I hope that I'll be invited back some later time. Yeah, Jeff, feel free to email me and I can connect you. You can get my email from the Everything ALS folks. And I can try to connect you with the people who actually are closer to Google Docs product development. But there's another branch of research that I briefly mentioned where we're trying to improve the speed of text input for people who aren't able to use their voice and for whom typing, just using their fingers on a normal keyboard, is no longer possible or is just way too slow. So they're using other assistive tech like eye gaze systems, and that's an earlier stage research project. But I hope that it will also result in a product that provides additional communication method for people like that. And thanks everyone for joining. I do see, recognize we're about at the top of the hour and folks are dropping, but it's really been wonderful to share this with you and interact, hear the questions, the comments, and I hope that it's useful for a number of people.
Bob, it's more useful than any of us realize because you're working every day, and tomorrow there might be something brand new that's going to come up. And so each one of us here just want to say, I hope you're taking care of your health, because your health is our wealth, and your team is priceless. And we cannot say enough about how important communication is. So thank you for taking that as your passion. And with that, we just want to hope that you can come back soon and bring us some new information. It's always exciting to see what you folks spend your time doing.